Welcome to this session 2. In the last problem, we understood how to solve the transportation problem if there is the warehouses or the factories in the market. And there is only two layers transportation where directly the materials or the goods are getting transported from the warehouses to the market points, or the goods are getting transported from the factories to the transport or the your market points. But in this case, in the real life, what happened? There are factories, there are also the distribution center in between, and there are also the marketing warehouses. So when the material is coming from the factory to the distribution center, and from the distribution center the materials are getting transported to the different warehouses, how to tackle the problem? And it's not that all the time the material are getting transported through the railways or through the roads. So there are all other different constraints, like it may be transported through the rails, through the roads, or through the ships, through the waters, channels and all. So whereas there are different mode of transportation, look into the different mode of transportation and look into the different constraint. So how to solve the problem in the transportations problem? Let us see a case. So the distribution unlimited C problem, it is a problem from the book of Hillier and Hillier book of management science. So there are two factories, factory 1 and factory 2, and they are producing 80 units and 70 units respectively. And there are warehouse 1 and warehouse 2 which need 60 units, and warehouse 2 need 90 unit. It's not 60, it's 90 unit warehouse 2 needs. So now let us see the problem. There is a distribution center in between the whole of factories 1 and 2 and the warehouse 1 and 2. So there is a distribution center, and each units here mean a full truckloads of material. So below the figure or the diagram being mentioned, regarding factory 1 and factory 2, and in between the distribution center DC, W1 and W2. So here let us see the uh, the constraints are that the trucks are available only to shift maximum of 50 units. So maximum of 50 units trucks can transport from through the roads, and for the rail there is no limit of transportation. So let us see the whole diagram of the uh, and the whole constraint and the cost attached to the different routes. So the below figure, it shows the distribution network available for the shipping in this product, where from F1 to F1 and F2 to W1 and W2, and DC is the distribution center. So let us see the diagram attached to this problem. This is all about the network diagram of the whole problem. So this is a network diagram where the directions are being shown, and the sourcing factories F1, F2, these are the nodal points, and W1, W2, these are another nodes, and DC is also nodes. So in total there are 5 nodes: 1, 2, 3, 4, and 5. These are 5 nodes. Let us see the different availability of transportation. So from F1 to W1 you can transport through the rail. Directly you can transport the material, and if you want to transport through the trucks, then you have to transport it to the from F1 to the distribution center through the trucks, and similarly from F2 to the distribution center through the trucks, and from DC to W1 and W2 again through the trucks, and F2 can also directly transport to the W2 through the railway network. But this is a case with perspective with relation to US market. So here transportation cost through the rail is costlier, and through your road is bit cheaper, maybe because of the price of the gasoline and the petrols. So but there are a constraint. Even if there is a need of 60 and 90 units of W1 and W2, there is a problem. Through the trucks you can transport only 50 unit at max. So through from F2 also you can transport 50 units, means the road can take care only of 100 units and truckloads of material, but when there is a requirement of 150 units. So these are the whole of network diagram. Let us see the cost attached to the different road in the network. So we saw the network diagram with the constraint 80 unit F1 can produce, 70 unit F2 can produce, and 60 unit W1 wants and W2 wants 90 units, and the constraints for the roads 50-50 units, and the rail is having unlimited capacity. So the cost per truckloads of material, if you want to transport through the rail, it needs $700 per unit, and if you are transporting through the trucks, it needs just $300 per unit. And you can see here 300, $200 per unit, $400 per unit, and here also it is $400 per unit, and it's all about if you are transporting through the roads. But if you are transporting through the rail, again F2 to W2, it costs $900 per unit. So now you have to take a call. When there is roads can take only 100 unit, how to transport 150 unit, how to allocate the material through the different routes. Let us see the solution. So all of us saw the whole network diagram, the cost attached through the diagram, and the constraints. So looking into the nodes, let us see the equation A14. A14 connecting factory 1 with the warehouse directly through the rail. A14, A13 transportation of material from the factory 1 through the distribution center. Max it can take care 80 units. Similarly, from the factory to A25 direct transportation plane through the distribution center, max it can take care 70 units. Similarly, the material that is getting directly through the from the factory A14 and from the distribution center A34, combined it should be 60 unit as W1 needs 60. Similarly, A to 5 direct transportation from factory 2 to 5, nodal point 5, and A to 5 and A35 should be at max should be 90, and it should be equal to 90. So distribution center here is it cannot store any material. It's just it can import material, and it can also allow the material to go. Distribution center does not store any material, so whatever material it is receiving from factory 1 and factory 2, A13 plus A1 A1 A23 should also getting transported. So A34 plus A35 should also be equal. So this is the constraint so far. Let us see how we can incorporate all those constraints in our solution. So this is about, so we can see the objective function of this equation also, like if you'll see x13 like material transported from the nodal 1 to 3, x13 into 300, x23 into 400. So look into the diagram, and x3 5 into 400. Let us see the pictures that. So this is the objective function we saw, the A14, the material getting transport from the 1 to 4 into 700. Can you see here? A13 and the material transportation cost 300, then A23, A23, then 400, A25, then it is 900. So combining it together, it is we have to minimize the cost, and we have to follow this constraint also. So let us solve this in the Excel, how we can solve it through the solver, the whole problem. So let us see the whole problem solution through the our Excel format. Is 700 dollar per unit. Similarly, from DC to W1, and the all the capacity of the route are being mentioned here. For the railway, it is unlimited, and for the road, it is we can see this is 50 unit max we can have. And now you want to suppose the shipping quantity here. These are the shipping quantity A14, A13, A34, A35, A23, A25. So here this let us see how much unit factory 1 is supplying. Sum if I'll do the sum if, then I can see this much quantity that F1 is supplying is 10 and 12 units. That should be 22. We are getting 22. See, the sum formula can take the range, then the criteria, and the sum range. So this the shipping quantity is getting added on the basis of this criteria from the node F1. So similarly from F2, how much quantity is getting supplied? If you look into it is 20 and 10, it should be 30. So let us see, let us calculate. So this sum formula is calculating how much quantity is getting supplied from F2. Similarly, how much material F1 is receiving? No material F1 is receiving. So two we have put the two criteria, and we are two material F1, F2 they are not receiving, so we are getting 0. Let us use the distribution center, the material it is receiving as well as it is supplying. So the outflow that it is supplying the material getting transported from DC, you can see 20 and 30 it is 50, and material that is getting received in so that is if you see here this is receiving 12 plus 20 32. So this is the way the we have put the this range is this column, and the criteria is DC J10, and this shipping is this column here. And we can see here this is the way the whole. Similarly we can get W1 and W2 here the warehouses 30 and 40. Let us see the how much the at the end how we can put them into constraint. So whatever the material this they are supplying, it is 80 plus 70. Here these are all 150 units, these are positive. The material the net W1 and W2 is receiving, they are not supplying anything, so they are minus 60 and minus 90. What is going out is positive, and what is getting in is negative. And DC is the center, whatever material they are receiving they are also supplying them out, so it is 0. So putting all these constraint in the data analysis in the solver, what we can see now, if I'll put all these constraints, so this is the total cost is nothing but it is the sum product of the shipping quantity and the total unit cost. So this is the total cost that I want to minimize, and the variable as these shipping quantities are my variable here. And if we'll see the constraint, if we'll let me delete all. So let me delete, then let me put one after other so that you all of us can understand better. So let us put all the constraint here. If I'll be putting the constraint, the first constraint, that whatever the material I'm receiving and whatever the material is going out, so add the first constraint, this should be equal to 0. So this should be equal to 0. Distribution center should be 0. Second, this material quantity that we are receiving, that should be less than equal to my quantity. Then the material which is the warehouse is receiving, this should be matching with the equal to this requirement quantity. Like this, I put all the constraint. Now let us see how we can solve this in the then another constraint, if I'll not take the road constraint, if I'll not take this road constraint, if I'll solve, then see it is coming 1 lakh, and these people are not sending anything through the railway, they are sending everything through the road. If the road constraint are not taken into consideration. If I'll take the road into consideration, so road into consideration, then what will happen? Then I have to add another constraint. So constraint, these are the constraint I have to add, and this is the this is the constraint we have to add, and so let us see. By adding this road constraint, max 50 unit it can transport. So let us see the solution. If you'll see, the whole amount is 1,10,000 dollars. So 1,10,000 dollars we want, and we can see through F1 and W1 we have to transport 30 unit, and F2 to W2 40 units, rest of the units 50, 30. So they are also maintaining this constraint also. So here you can see also net flow 80 and 70, and these are all being maintained. So this is the way, even if you put any other shipping quantity of your initially, so we do not know, suppose I'm putting this rough quantity and we want to solve uh, again, putting all these conditions, so so to see the, and this is the way the whole problem is getting solved. We also found this net flow, they are also matching, and we are also